Okay, so operating with vectors. Operating as in like adding, subtracting, multiplying, dividing. Let's say I'm given two vectors that look like this. Vector u is negative 1, 3. So negative 1, positive 3. Vector v is positive 4, 1, 2, 3, 4, positive 6. 1, 2, 3, 4, 5, 6. All right? Now remember, these written like this, the component parts of these vectors, they don't actually matter. It doesn't actually matter where it is. So for example, this vector u, as long as it goes left 1 and up 3, I can have that u be over here. It's the same vector. These two vectors are exactly the same. I can have the vector be over here as long as it's exactly the same. Yes? So I can move this vector wherever as long as that angle stays the same and the magnitude stays the same. And v, same thing for v. So v is the same vector as long as I move over to the right 4 and up 6. Right? So what does it mean if I add u plus v together? Well, basically the two forces here, this vector plus this vector, we connect them head to tail. We call it head to tail. So we start with either one, u or v. It doesn't matter because here's u. So I'm going to start with u, which is the original one from the origin. This u here. If I want to add the vector v to this, I basically put the head of this vector to the tail of this vector. So the v that used to be here, that's the same no matter where I move it. V used to be here. But my v I can really place anywhere. So where the last vector ended, I'm going to start it there, and I'm going to push it all the way over this way. Okay? So v, I'm going to move over 4 and up 6 to create my shifted v. So this v, I'm going to shift over here. So I'm going to, from this point, I got to move over 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. Right? So again, this is where my vector v used to be, but I'm adding it to the vector u. Now the new vector of u plus v is this right here. This is my vector u plus v. So my vector of u plus my vector of v, it's not the same as v, by the way. V is up here shifted. This u plus v is actually more steeper, more steep. So what is the component value of u plus v? Well, I moved over 1, 2, 3, and I moved up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, can I find that without actually drawing it out? What if I don't want to draw it out? So u was equal to negative 1, 3, right? So negative 1, positive 3. V was equal to 4, 6. Moved right 4, up 6. Now this vector right here is the vector of u, my new vector of u plus the v, which I found to be 1, 2, 3 to the right, and then 9 up. Now how does that relate to these numbers right here? If I basically just added these two x components. Negative 1 plus 3, I added it to give me 3. I added these two to give me 9. So why does that work? Well, to get up to this point, my x, what did I do on the x? I moved left 1, and from here, I moved right 1, 2, 3, 4. So left 1 and right 4 is essentially left 1, right 4 is essentially just 3 to the right. Same thing for the y. I moved left 1, but I moved up 1, 2, 3, and from here, I moved up 6 more. Right? So I'm just adding this 3 over here with this 3, this 6 over here. So the 3 plus 6 will give me 9. Okay? What happens if I multiply, for example, 3 times u? U, again, once again, it was -1, +3. 3 times u is going to be, it's the same thing as u plus u, right? 3 times u. So that means this initial u, I'm just going to triple it up. I'm going to add 2 more of those u's. This is my first u here. Head to tail, I'm going to go over 1, up 3 again. Over 1, up 3 again. That's my second u. And I'm going to add a third u, going over 1, up 3. So now what is, from the origin out to the end here, it becomes one gigantic vector. 3u is going to equal to 3 times the vector -1, right? It's going to go -1, another -1, another -1. So it's going to go -3. So it's 3 times that -1 from up here. And then it's going to go 3 times the vertical distance. 3 times that vertical distance. So it's going to go up 3, 3 more, 3 more. It's going to be -3, +9. Easy enough. What happens if I subtract? What if it's u minus v? Well, it's the same idea. If it's u minus, no, let's go back. How do I do -1 times v? So the vector v, I'm going to negate. Vector v, I'm going to negate. Now if I multiply this by -1, in the same way I multiply by 3, I just have to distribute that 3. I'm tripling up the x value, tripling up the y value. If I negate v, I'm basically going to take the x value, negate it, and the y value and negate it. So this is going to give me -4, -6. So that vector in comparison, from here, instead of going +4, +6, it's going to go -4, -6. So my vector -v is going to be way down here. It's going to flip. So this is where my v used to be, but I'm negating it. -1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this becomes my negative vector v in comparison to this positive v. So you see how it goes in the opposite direction? This is obvious, but then now I'll have to say, what does it mean if I do? So once again, u was -1, +3. V was 4, 6. What does it mean if I do u minus v? Obviously, algebraically, that's pretty straightforward from everything that we've been doing. I do -1 minus the 4, and then the 3 minus the 6. It should give me -5, -3. Conceptually, what does that mean? Well, u minus v, I can make it so that it's u plus -v. Then you can add the head to tail. So my u, in this case, the order definitely matters. So the u here is going to be -1, +3. It's the same. It's this guy, which I can't. Oh, my graph size changed. So -1, +3. This is my u. -v, remember, -v on this side went the opposite way. So -4, -6. So from here, From head to tail, I'm going to go negative 1, 2, 3, 4, negative 1, 2, 3, 4, 5, 6. This is my negative v. So I'm adding u plus negative v. That's what conceptually, that's what this means. Yes, this is algebraically. Conceptually or graphically, you could think about it that way. So where is the vector? What is the vector u minus v? It's from here out to here. This is the vector u minus v. And if you take a look, it should be negative 5, negative 3, negative 1, 2, 3, 4, 5, negative 3. This is my vector u minus v at negative 5, negative 3. Okay? And now you are ready to finish the homework assignment for tonight, which is page 511 from, what did I say, 3 all the way up to 17. So instead of up to 12, you're going to finish all the way up to 17. This is all due on Monday. Okay, that's it.